mathematics. And you're probably used to the word in everyday language. Transformation means something is changing. It's transforming from one thing to another. So what would transformation mean in a mathematical context? Well, it could mean that you're taking something mathematical and you're changing it into something else mathematical. That's exactly what it is. It's talking about taking a set of coordinates or a set of points and then changing them into a different points along the sides too. There's a bunch of points along this. You could argue there's an infinite, or there are an infinite number of points along this quadrilateral. This right over here, the point x equals 0, y equals -4. This is a point on the quadrilateral. Now, we can apply a transformation to this. And the first one I'm going to show you is a translation, which just means moving all the points in the same direction and the same amount in that same direction. And I'm using the Khan Academy translation widget to do it. So let's translate. Let's translate this, and I can do it by grabbing onto one of the vertices. And notice I've now shifted it to the right by 2. Every point here, not just the orange point, has shifted to the right by 2. This one has shifted to the right by 2. This point right over here has shifted to the right by 2. Every point has shifted in the same direction by the same amount. That's what a translation is. Now I've shifted, let's see, if I put it here, every point has shifted to the right one and up one. They've all shifted by the same amount in the same direction. That is a translation, but you can imagine a translation is not the only kind of translation.
So now I would like to, for you to go to your graphic organizer, and we're going to take some notes about translations. A translation, under what is it? It is a slide or shift. In the next column, it says, what operation do we perform? When you're performing a translation, it is addition, or you're going to subtract. During a translation, what happens to the size? It stays the same measure of congruency. This is the academic language that essentially means nothing changes about its size. And also, what happens to the orientation? It faces the same way which means it preserves orientation. I want to show you a short demonstration using a football. So we see the football, and if I just shift it or slide it over, that is a translation. Nothing about the size has changed, nothing about the position or orientation. It's still facing the same direction, it's just simply being repositioned.
So, for example, I could do a rotation. So I have another set of points here that's represented by quadrilateral, I could call it CD or BCDE, and I could rotate it. And I would rotate it around the point. So for example, I could rotate it around the point D. So this is what I started with. Let me see if I can do this. I could rotate it like, let me see. So if I start like this, I could rotate it 90 degrees. I could rotate 90 degrees. So I could rotate it like, that looks pretty close to a 90-degree rotation. So every point that was on the original set of points, I've now shifted it relative to that point that I'm rotating around. I've now rotated it 90 degrees. So this point has now mapped to this point over here. This point has now mapped to this point over here. And I'm just picking the vertices because those are a little bit easier to think about. This point has mapped to this point. The point of rotation, actually, since D is actually the point of rotation, that one actually has not shifted. And just so you get some terminology, the set of points clockwise rotation around the point B. And so this new set of points, this is the image of our original quadrilateral after the transformation. And I don't have to just, I'm going to do this, I don't have to rotate around to just one of the points that are on the original set, that are on our quadrilateral. I could rotate around to the origin. I could do something like that. Notice it's a different rotation now. It's a different rotation. I could rotate around any point. I also did another transformation.
So here we are back with our notes, and we're going to take a few notes on rotations. I would like for you to flip over your graphic organizer, and on the back talks about rotation. And I did not include the headings on the back side, so if you want to write those in really quickly, what is it? The operation involved. What happens to the size? And then what happens to the orientation? Okay. So with a rotation, it is a turn. The operation, you're going to change the sign of X and Y. Change the sign of X and Y. Also, we'll switch the order of X and Y. Order of X and Y. What happens to the size during a rotation? It stays the same measure of congruency. This is academic language that essentially means that nothing changes, or it maintains the same dimensions, which are size and shape. And then for the orientation or the positioning, so we can make ourselves a note that this means position. It does not face the same way. We're going to use the football example to briefly just demonstrate a rotation. A rotation, you turn the object. That could go to the right or left. And if you notice, while the size of the football does not change, the orientation does change. It does not face the same way. If you look at the nose of the football, the larger end is pointed towards the upper left-hand corner. And when I rotate it, now it's pointed towards the upper right-hand corner. So it does not face the same way. But the size remains the same.
A reflection. And you know what reflection means in everyday life. You kind of imagine the reflection of an image in a mirror or on the water. And that's exactly what we're going to do over here. So if we reflect across a line. Let me do that. So this was this 1, 2, 3, 4, 5. This not irregular pentagon. Let's reflect it. And to reflect it, let me actually make a line like this. I could reflect it across a whole series of lines. Whoops. Let me see if I can. So let's reflect it across this. Now, what does it mean to reflect across something? One way I can imagine is if this was, we're going to get its mirror image, and you kind of imagine this as kind of the line of symmetry, that the image and the original set of the original shape, they should be mirror images across this line. We can see that. Let's do the reflection. There you go. And you see we have a mirror image. This is this far away from the line. This corresponding point of the image is on the other side of the line, but the same distance. This point over here is this distance from the line, and this point over here is the same distance, but on the other side. Now, all of the transformations that I've just showed you, the translation, the reflection, the rotation, orientation.
Now we turn our attention back to our notes, and we want to flip our page over and talk about reflections. A reflection is a flip. In the mathematical operations, you change the sign of x to reflect across the y-axis. Sign of x to reflect across the y-axis. And conversely, you change the sign of y to reflect across the x-axis. What happens to the size? Again, it stays the same measure of congruency. We know that the same measure of congruency is academic language that essentially means nothing changes. So we're going to mark ourselves a note that nothing changes. And what happens to the orientation? It does not face the same way.
We're talking about the idea of transformation. In particular, we talk about rigid transformation. So, for example, you can shift something. This would be a translation. So the thing that I'm moving around is a translation of our original triangle. You could have a rotation. So that thing that I translated, I am now rotating it. There. And you can also have a reflection. The tool that I'm using doesn't use reflection. But that's essentially flipping it over. What we're going to talk about in this video is a non-rigid transformation. And what makes something a rigid transformation is that lengths between points are preserved. But in a non-rigid transformation, those lengths do not. So, for example, this rotated and translated triangle that I'm moving around right here, I'm continuing to translate it as I talk. I can dilate. And one way to think about dilation is that we're just scaling it down or scaling it up. So, for example, here, I'm scaling it down. That is a dilation. Or I can scale it up. This is also a dilation. We're going up and down. So the whole point here is just to appreciate that we don't just have the rigid.
So back to our notes to talk about dilation. You will have to flip your paper. A dilation is it's when it gets bigger or smaller. So we're going to write gets bigger or smaller. The mathematical operation, you multiply x and y. And what happens to the size? The size changes. This is the outlier. It's the only one where the size changes. And it could be bigger or smaller. And then finally, with the orientation, it faces the same way. This also means it preserves the orientation. Let's take a look at an example using our football. And we see with our football example, dilation is when it gets bigger or when it gets smaller. Notice